This is lesson 2.4, use linear gradient and radial gradient. So what are gradients? Gradients lend a depth to surfaces and backgrounds by gradually varying the color of an object's fill property. A gradient is a smooth transition from one color to another, and the endpoints of these transitions are called stops. Stops are placed at fractional offsets between 0 and 1 and later scaled to fit into the areas chosen for the gradient. Stops also have color and offset attributes. Now, if a gradient doesn't fill an entire region, a cycle method has enums that specify how to fill it. No cycle fills the target region with terminal colors. Reflect reflects the gradient pattern start to end and end to start continuously until the target region is filled. And repeat repeats the gradient pattern until the target region is filled. Now, in general, you should use linear gradients with rectangular shapes and radial gradients with circles and ovals. Let's look at linear gradients first. So what are linear gradients? Linear gradients describe color transitions along a line given by endpoints. The coordinates of the endpoints are fractional values between 0 and 1, and the line is scaled relative to the area painted by the gradient. The default is a horizontal transition filling the entire area, but you can specify vertical linear gradients too. And changing the direction of the line changes the direction of the gradient. Here are the properties of a linear gradient. Start x and start y are the xy coordinates of the gradient's start point. End x and end y are the ending coordinates of the gradient. Proportional indicates whether the start and end locations are proportional or absolute. Cycle method defines which cycle method is applied to the gradient. And stops is a sequence of two or more stop values that specify how to distribute colors along the gradient. Let's show you a JavaFX program now with linear gradients. This is the LinearGradient program that shows you how to use linear gradients. Let's compile and run this program and see what it displays. What you see on a gray background are three rounded rectangles containing linear gradients. All the linear gradients are transitioning colors from orange to brown. The top rectangle has a vertical linear gradient. This shows how the orange color at the top transitions to a brown color at the bottom. The middle rectangle has a horizontal linear gradient. Here, the orange color transitions from the left to the brown color on the right. And in the bottom rectangle, we show a diagonal linear gradient that reflects the orange to brown color transition. Let's look at the code now that creates these rectangles and applies the linear gradients to each one. The makeRectangle method creates each rounded rectangle. The first argument is the y-coordinate of the top left corner of the rectangle. The second argument is a scale x factor, and the third argument is a scale y factor. These scale factors determine the orientation of the linear gradient in this program. For a vertical gradient, scale x is 0 and scale y is 1. For a horizontal gradient, it's the opposite. And these values for scale x and scale y help create the diagonal linear gradient. And you will see how these scale factors are used shortly. Here's where we add the three rectangles to the root scene graph. Now let's look at the makeRectangle method. This method creates a rectangle at an xy position with a specified width and height. These setters create the rounded corners. And here's the call to do linear gradient with the scale factors. Note that this method returns a linear gradient for the fill color of the rectangle. Let's look at this method now. The doLinearGradient method has two arguments for the scale x and scale y factors. This method also creates the linear gradient for each rectangle. Here we specify the starting and ending coordinates of the gradient. Note how the scale x and scale y factors are applied to the end coordinates. This is how the program creates the vertical, horizontal, and diagonal gradients that we showed you. Here we set proportional to false and use reflect for the cycle method. And the stop array starts the transition with orange and ends it with brown. Recall that reflect for the cycle method makes the gradient reflect from start to end and end to start to fill the rectangle. Let's change it to repeat and see what happens. When you recompile and run the program, you can see that the diagonal gradient has changed. Instead of reflecting the orange to brown color transition, it repeats it. The other gradient in JavaFX is a radial gradient. So what are radial gradients? A radial gradient describes a color transition along the radius of its circle defined by a center point, focus point, and radius. The first stop in a gradient is mapped to the focus point, and the last stop is mapped to the perimeter of the circle. Focus points also default to center points if you don't provide one. Now, why would you use radial gradients? Radial gradients work really well with circular shapes, and you can interpolate between two or more colors. Radial gradients also make circular shapes appear three-dimensional. Let's show you the properties for a radial gradient now. Focus angle is the angle in degrees from the center of the gradient to the focus point to which the first color is mapped. Focus distance is the distance from the center of the gradient to the focus point to which the first color is mapped. Center x and center y are the xy coordinates of the center point of the circle defining the gradient. Radius is the radius of the circle defining the extents of the color gradient. Proportional indicates whether the center and radius values are proportional or absolute. Cycle method defines which cycle method is applied to the gradient. And stops is a sequence of two or more stop values that specify how to distribute colors along the gradient. Okay, let's show you a JavaFX program now with radial gradients. This is the My Radial Gradient program that shows you how to use radial gradients. Let's compile and run this program and see what it displays. What you see on a gray background are three circles with different radial gradients. All the radial gradients are transitioning colors from white to dark green. In the first circle, the center point of the gradient is in the lower left part of the circle. In the second circle, the gradient's center point is in the middle of the circle. And in the third circle, the center point of the gradient is in the top right part of the circle. Let's look at the code now that creates these circles and applies the radial gradients to each one. The makeCircle method creates each circle. The first argument is the x-coordinate of the circle's center point. The second argument is center x for the radial gradient, and the third argument is center y. These values make the gradient center in the lower left part for the first circle. These values make the gradient center in the middle of the second circle, and these values put the gradient center in the top right part of the third circle. And here's where we add the three circles to the root scene graph. Now let's look at the makeCircle method. This method creates a circle with radius 40, and the setter method set the circle's center point. The call to do radial gradient with the gradient's xy center point returns a radial gradient for the fill color of the circle. Let's look at this method now. The doRadialGradient method sets the focus angle and focus distance to zeros. The gradient's center point is set to the xy arguments. The radius is 0.5, proportional is true, and cycle method is set to no cycle. The stop array starts the transition with white and ends it with dark green. Note how the radial gradients make the circles look three-dimensional. To see how important this is, let's change the fill color of each circle to just dark green without a radial gradient. When you recompile and run this program, here's what it looks like. And you can see that the circles now appear two-dimensional.